Welcome to lecture 30. This is a revision lecture in which we will revise the concept of computing equivalent impedance given a resistance, capacitive reactance, and inductive reactance. So in example 1, we'll solve a number of examples here. In this example, we have a resistor of value 1 ohm is in series with a capacitor whose capacitive reactance Xc is minus J 5 ohm. This we generally write as CR and this as CC. This impedance is 1 ohm, this impedance is minus J 5 ohms. So we can write the equivalent as CR plus CC. Why plus? Because they are in series and we know that the impedances are added if they are in series. 1 plus minus J5. This is 1 minus J5 ohms. This can also be written in polar form. This is in rectangular form where this is X and this is Y. The real part, the imaginary part. We can also write it in polar form. How? By using this expression R square root of x squared plus y squared. 1 squared because x is 1. This is minus 5. Y is minus 5. So 1 plus 25 square root of 26. Theta is inverse tan of 5 over x is inverse tan of minus 5 over 1. We can use calculator to find its value. And then we can write it in the form of r at an angle of theta in polar form. So converting between rectangular and polar form can be through this formula, or you can use calculator to directly convert a number from polar to rectangular to polar, or otherwise, vice versa. In this second example, the equivalent impedance is 1 plus J2 CR plus CL, 1 plus J2 ohms. It can also be converted into a polar form like this. When we have, in third example, we have this 1 ohm and J1 ohm in parallel. So we can write it as 1, or in other words, we have studied that 1 over, in DC we studied 1 over R equivalent is 1 over R1 plus 1 over R2. Here we have 1 over C equivalent is 1 over CR plus 1 over CL. Or it can also be written as C equivalent is CRCL over CR plus CL. Or we can go along with this expression 1 over 1 plus 1 over J1. 1 over 1 is a 1 plus 1 over J1. We know that 1 over J is a minus J. Minus J1. Inverting the whole, C equivalent becomes 1 over 1 minus J1. We can either rationalize it by multiplying it with its complex conjugate. This becomes 1 plus J1 over 1 squared plus 1 squared is 1 plus 1 is 2. So we can also convert it into the polar form using calculator or by hand like this. Right. If we have this scenario, let me draw it again over here. We have a resistor, an inductor, maybe a J1 ohm inductor, capacitance minus J1 ohm. Suppose this is the case and we are required to find this C equivalent. This means since they are in parallel, we can also use the same formula which we studied in O levels, A levels, and FSE. This is 1 over J1 plus 1 over minus J1. This minus can be written here. So this is 2. 2 why it becoming 0. Right, 1 over J1 minus 1 over J2. So 1 over J is minus J. You can write it as minus J1 this 1 over J minus J plus J 1 over 2 is 0.5. So this becomes minus J 0.5 or it can be written as 0.5 at an angle of minus 90. Right. If we have this is an example and we want to solve it for the C equivalent. We have these two in parallel plus this 2 ohm in series. So we can write it as 2 plus J3 and minus J4 are in parallel. So this is 1 over J3 plus 1 over minus J4. We can solve this mathematics to find the C equivalent. We can try different examples to find equivalent impedance in different cases. If you have questions, please post me on my email address or on MS Teams. Thank you.